AI agent routing bit us on a content pipeline in a very boring way, which is usually how production fails. The renderer returned a non-zero exit code. The file did not exist. Instead of a hard-coded failure edge, we asked a model, what should happen next? It saw the log summary, guessed the render was probably fine, and chose the publish edge. We shipped a broken artifact to staging, and burned the next morning tracing a decision that should never have been a decision. The bug was not the model being weird. The bug was giving it a route that code could have chosen. The naive agent graph says, here is the state. Pick the next node. That feels elegant because the model can adapt. But every edge the model chooses is an edge you cannot fully predict. Flexibility and instability are the same feature. If the condition is checkable, model routing adds noise without adding intelligence. Exit code 0 or not 0 is not a language problem. A JSON schema either validates or it does not. A cost budget is either exhausted or it is not. When you ask a model to route those cases, you make the graph harder to test, harder to replay, and harder to explain after an incident. The pattern is a routing ladder. First, deterministic checks route in code, always. If the condition can be measured, parsed, validated, counted, or compared, code owns that edge. Second, if the decision is fuzzy, but you can define a rubric, compute or request a score, and route against a threshold. Third, and only third, use model judgment for genuine interpretation calls, where the right answer depends on meaning. This is opinionated, but it has held up well in production. Models should produce work and interpret ambiguity. They should not be the traffic light for facts your runtime already knows. Mechanically, build the router as a normal function around the graph, not as a prompt hidden inside a node. Give it the current state and make it return a route name plus a reason. Start with hard checks. Process exits, schema validation, missing files, rate limits, token budget, retry count, time budget, safety flags, and required fields. Then apply rubric scores, relevance, completeness, confidence, novelty, or risk. But only if the scoring method is defined. Only after those gates pass do you call a model router. And even then, restrict the output to named routes, with a short rationale and the evidence it used. Take a content pipeline. A planner proposes 3 episode topics. A writer drafts one. A renderer builds the final asset. The bad version routes everything through a model. Should we retry, repair, publish, or pick another topic? The reliable version splits the edges. Render failure is pure exit code. Non-zero means retry render, then fail after the retry budget. Metadata problems are pure schema validation. Invalid JSON goes to repair, then back to validate. Quality below a threshold goes to review. The one model routed edge is topic pick, because choosing the strongest topic from audience goals and source notes is an interpretation call. This pattern does not make routing magically safe. Deterministic checks can be wrong if they check the wrong thing. A process can exit 0 and still write corrupt output. A schema can validate structure while the content is useless. Thresholds drift as your data changes. Rubric scores can become cargo cult numbers if nobody samples the borderline cases. And model-routed interpretation can still be inconsistent. The trade-off is not perfection. The trade-off is isolating uncertainty. You want the small part of the graph that needs judgment to be visibly judgmental, and the rest to be boring, replayable engineering. In the graphs tier, routing is where your loop architecture becomes real. Nodes do work. Edges decide what work happens next. If edges are vague, the whole graph is vague. This connects directly to state design because the router needs clean facts to inspect. It connects to verification because validators create routable evidence. It connects to budgets because retry and spend limits are routing rules. And it connects to orchestration because a fleet scheduler cannot manage graphs whose decisions are invisible. An edge you cannot predict is an edge you cannot test. Here is the 10-minute exercise. Open one automation you already have and list every edge. Retry, repair, continue, escalate, stop, publish, archive, anything. Next to each edge, write the condition that triggers it. Now mark every condition that is checkable by code. Exit codes, schemas, file existence, counts, thresholds, budgets, required approvals. Move those out of prompts and into the router. For the remaining edges, ask whether a rubric score would be enough. Only leave model routing where interpretation is genuinely required. Finally, add a routing log with 3 fields: decision, evidence, and rule fired. That log is your future incident report. 3 beats to close. First, checkable condition means code route always. Exit codes, schemas, thresholds, budgets, and counters are not model questions. Second, use the routing ladder, deterministic check, rubric score, model judgment as the last resort. Third, log every routing decision with the decision, the evidence, and the rule that fired, because unlogged routing is folklore. In AI agent routing, the goal is not to remove model judgment. The goal is to spend it where it buys you something. This is loop engineering, daily on this channel, building reliable agent loops that finish, verify, and stop.